Okay, I just want to thank everybody for phoning in. This is the 8th session in the IBIU BIM series. Today we're covering building, civil, and plant-based software or BIM authoring tools. We'll have a couple of interactive polls along the way, so I'd welcome any participation as appropriate. So just a reminder, this session is approved for AIA credits through the continuing education program through the American Institute of Architects, qualifies for 1 learning unit, and again, of course, it's copywritten to IBI. So those who are AIA members, please do enter in your AIA number in the questions pane, and I will I'll review any other questions accordingly, but that's where we're tracking the AIA numbers. If you're sitting in a conference room, please fill out a sign-in sheet, and if you're also an AIA member, write down your AIA number, and then we'll email that to ibiu@ibigroup.com. For all other Con Ed programs across Canada or the United Kingdom or elsewhere in the globe, you'll have to self-report using the certificate provided to you by IBIU. So this course specifically today will explore what software is available, and it will not be all-encompassing by any means, but we're going to touch upon the different types of software that's out there, some of the pluses and the minuses, things to look for, some particular note on interoperability, and how to deal with differences between building, civil, and plant-based modeling. So the learning objectives, understand some of the software that's there, the differences, how to bring models from various software together into a single model, usually for review purposes, and then understand a bit about the BIM execution plan when you're selecting software. We'll definitely get into more details on execution planning in some subsequent sessions, but we'll touch upon it today. So we'll recap from the previous sessions first, very quickly. BIM is both a noun and a verb. From the perspective of the verb, it's the process involving the generation and management of digital information about the physical or functional characteristics of places. And these would be the assets you see in the rooms around you or in the environment, in the spaces within which you live. Everything you see can be designed and modeled and have some sort of information attached to it. BIM, the noun, are the files themselves, whether it's one model, many models, collection of information, the synergistic relationship between them all, and it allows you to make decisions either as individuals, businesses, agencies, or across designing, constructing, and operating our various assets for multiple infrastructures. And it does span the I, the B, the I, so it can be a building, a linear infrastructure, or a system, which is a collection of information or asset data. Collaboration and planning are critical, and when we talk about that, there'll be a session talking about BIM collaboration later on, but this forms part of how you plan. You've got to know, if we're going to BIM, we've talked previously about what you BIM and why you BIM. This is going to get into the how you're going to BIM as well with respect to software. BIM is essentially geometry plus data, so regardless of the software you're using, you're going to model something. You're going to know a bit about what that something is, and from that little bit of what you know, you can do something with that data. If you have a lot more data, you can probably do a lot more things. If you have less data, you can do focused things. BIM is also linear from a macro to micro perspective within the space or the geography within which we live. This example here is showing the curb that's part of a bridge, that's part of a road, that's part of an infrastructure. So again, macro to micro. If you're applying it to buildings projects, again, you can go right from the the table in the room out to the macro level of the building, and then beyond into this exact geometric infrastructure as shown here. We talked about lifecycle data management in the last session, so we looked at asset management and what that means when you're modeling a specific asset, and the unique IDs are tied to other sources of information. This example here is showing it being tied to a schematic, a spec, operational diagram, a computerized maintenance management screen, or a SCADA screen for operations. One asset, various streams of information. BIM is one of the mechanisms that can pull that information together and portray it accordingly. We talked about BIM uses, and this goes back to the second session. So we actually explored each and every one of these. So when you sit down on a project and you say, well, why would I do BIM? What's the benefit? Well, we would do it for what we call these base BIM uses. So without getting into the depths of what BIM can do, we would grab a BIM authoring tool and we would hopefully make ourselves more efficient in producing our drawings and schedules to satisfy contract documents, to visualize and understand, and to further produce advanced visualization, either renderings or animations, photorealism, whole separate tasks, but we can feed into that, and then to do full-out design and or construction review. All the other items around this wheel, you could not do them. The value proposition needs to be looked at, understood, and mitigated within the confines of each and every project, whether it's design, bid, build, P3, etc. There's pluses and minuses. In the first session, we brought up this slide, and I promised down the road we'll talk about it. So this is the down the road now. But in the industry, when we talk about software, there could be the never-ending gambit of what you could use. But most often, our vendors are divided into a couple pockets: building, plant, and civil. And the reason for that is within each of those three realms, there's various types of information that can be exchanged or understood or is common. So on the building side, you can analyze for structural energy, movement of people, daylight infiltration. You can generate room schedules, doors, quantity specific to buildings, have exchange mechanisms with project specifications. On the plant side, the analysis is really what's unique there, where you can get into pipe stress analysis or hydraulic leveling or process flow diagrams, as well as that data exchange. That term P&ID is a process information diagram, so you can exchange information from the 2D schematic to the 3D model and vice versa. Very heavily done in advanced industrial or plant-based modeling, power plants, water treatment plants, etc. And then on the civil side, the analysis of terrain modeling and undulations of landscape, subsurface terrain leveling, the generation of digital terrain models that then can be graphicized or vectorized, if you will, into a graphics model that can then be associated to buildings or plant models, but really represent the triangulation of the landscape within which we're affecting a change. Once you have this software, we utilize it wrapped around some base fundamental platforms, how we collaborate, how we review our base CAD, and I want to stress there, CAD being AutoCAD or MicroStation, depending on the delivery requirements for the project or what's being utilized for preference or for experience, whatever the case is, and wrapped around how we're going to harness and report our data, coupled with our IT infrastructure, so servers, desktops, connectivity to the cloud, etc., and allows us to focus on what does the owner want? And that's always the biggest question, and it should be the first question. What has to go to the owner? What has to go to others? And how do we expect it to get there? This here is, I would say, if you could answer all these questions, you've done your BIM execution planning, and you can fill out the plan accordingly. But it's about that data exchange and how are you, once you know what you have to exchange, how are you going to make the models? How are you going to ensure the data is there? How are you going to deliver? How are you going to collaborate? Whole bunch of questions fundamental to how we're doing BIM. But as I said back in the BIM uses, if you're just doing BIM internally for efficiency relative to your own design process, that's very different than harnessing BIM to achieve exchange with external repositories when prescribed. The other thing we mentioned maybe 3 sessions ago was there's a whole thing around information exchange. So knowing that there's multiple pieces of software out there, and knowing that, especially on major projects, there's no way you can 100% control who uses what when. So some ISO standards have been developed focusing on the exchange of geometry and data to facilitate multiple software vendor workflows. Now, I'll be the first to say, if everything is in Revit, it's much simpler than if you have multiple tools at play on a project, or if everything's in Bentley, or if everything's in Civil 3D, whatever the case is. But especially in my experience, I would say 9 times out of 10, there's more than one thing at play. So ISO 15926, that's your plant data exchange. So when we talk about the plant tools, that standard looks at exchanging the information for pipes and valves and fittings and stuff of that nature across the various tools. ISO 16739 is your industry foundation classes. So it's the ISO standard that governs the IFC file that allows you to exchange building-based data between tools like Revit and Bentley's EcoSim and ArchiCAD and Vectorworks, etc., and Tekla, all of those ones. COBE is a spreadsheet-based system that takes data, formulates it to get it ready for facility management to focus on turnover to a client. Its main focus has been facility management within buildings, but the UK has a task group that's looked to extend this to include what they term Civil BIM for their linear infrastructure projects in support of what they call data drops across the life cycle of a project. And then the last one I want to mention, FIATech, stands for Fully Integrated and Automated Technologies for Construction. It's a great organization. It's not for profit, and its sole focus is lifecycle data interoperability. So I've been involved with them over the past decade or so, and it's really fascinating when you go to the table with nothing but my data, and how do you make data talk? That's the focus of FIATech, and it's a rather exciting organization, I think. The BIM execution plan, when we have the session on the project BIM lead, early September, we're going to talk a lot about this, but the gist for this call is there are templates available from Penn State for North America, CPIX in the UK. IBI is working to standardize an approach on how to go about setting up a BIM execution plan, grabbing your template, filling it out, holding ourselves accountable for implementing it. It can be informal or formal, but you just need a plan. You've got to understand what you're doing. So what are your BIM goals? Do I want to have design review, efficiency in drawings? Do I want to have advanced visualization? Do I want to send my steel model to the fabricator? Whatever the BIM goal is, what are the BIM uses, so around that wheel of BIM that we're going to use to harness to achieve the goals? Just how are we going to do it? That's the big question. And lastly, scope, schedule, budget, quality, risk are the 5 project delivery words that should be on everybody's mind. I love this diagram that's used in our project management courses. You knock off any one of those vertices, the triangle fails. You try to do more than the allotted for scope, schedule, budget. The triangle explodes. You try to do less, the triangle implodes. You need the right balance. BIM fits into the quality system that's being driven by scope, schedule, budget on your project. Okay, we're going to talk about the building tools now, and before I do that, I'm going to launch this first poll, and what I'm asking is select whichever ones you are familiar with relative to building software. So have you heard of any of these? Not necessarily use them or experts in them, just are you aware of their existence? And as I said, this slide is not all-encompassing, and as you can see, I only have 5 of them in the poll because the poll only allowed me to have 5. So that's just is what it is. So it's awesome. So everybody who's responded has heard of Revit. That's pretty cool. 50%-ish ArchiCAD, 40%-ish Vectorworks, Tekla 23, EcoSim roughly 14. So that's pretty cool. So I'm going to stop the poll now. Okay, so the poll's closed, and you all should be seeing my screen again. Let me just verify that. Good, okay. So what we're going to talk about, what I figured for the building is, I want to just show some of the similarities. Because oftentimes when I look at building tools, and any of these BIM authoring tools, they're often what I describe, they're doing the same thing with a different essence, if you will. So looking at painting here, oil versus a watercolor, at the end of the day, 2 different medium, 2 different approaches. The end result is a painting, but it's different. You achieve an image, you achieve the intent, the fine details of an oil painting versus a versus a watercolor painting are different, yet the result gets you to convey the message to the viewer relative to the scene you were trying to portray. So if I take that and apply it, what I'm going to do on these slides is just show some of the differences between Revit and Bentley, but more so the similarities. The point of this, I'm not trying to sell one over the other, over EcoSim, over ArchiCAD or Vectorworks, but just to show you that the intent of these building BIM tools are very common. So looking at levels, when you start up models, you have floors that are defined. The relationship between one floor and another is stated, and then those floors govern that relationship between components that go from floor to floor, etc., and can be augmented throughout the course of the project. Walls are very similar. You have a predefined set of walls, depending on what your templates are within a company, and IBI has quite a robust Revit template, so you're all aware. You're able to select or load various types of walls. You can place them, you enter in your height, your X, Y, you get your wall. It comes complete with however many layers of the wall you want, and it's placed. Same with the floor. You can place your floor slab dependent on whatever options are available. And notice in the Revit and Bentley, they're similar in nature in that you have a pull down selecting what you're going to pick. You have particulars with respect to thickness, whether the thickness is fixed or whether it's variable, and then you're able to place your floor on the plan. Doors punch through the wall, so there's association. The walls host the doors, therefore it manages the relationship between any of the openings relative to the components that you're placing. Same with the windows. Same with the curtain walls. Curtain walls are fun because there's so many different ways you can make it, but it depends on, this gets back to content library and what's available, what's at your disposal for placement, whether you're doing an IBI only project, a joint venture project, etc. Same with the roofs, and you can see it's a very simple model. Concept is just to show that you're able to place in a similar manner. You can flood, you can place by points, you can select the type of roof, the shape, the slopes, mandrel versus gambrel versus slope versus hip, etc., whatever you want to do. And then depending on the nature of the tool, you get into specifics of what comes out of the box versus how it appears. Here was a great example where just placing a simple stair, the Revit had the stringer, the Bentley did not. So what does that mean? Well, you have to accommodate for that depending on the tool you're using. The out-of-the-box handrail, the default, it depends on what's available and what's loaded into your model. You can place tagging, so this allows you to pick any piece of data. This goes back to place your component plus data. If I have a door number, I can place it. If I have any parameter or any data field entered, I can place it, and it will build an association to the modeled component. And you can do this for any component placed on your models. Again, the critical thing is what exactly is there to be placed? Is it consistent? Do you have an approach defined on your project or an approach defined firm-wide to ensure it's achievable? And the similarities, they keep coming in. You can place your structural columns depending on what's available for placement. Both tools have a wide range of industry standard steel shapes. You can load them up from anywhere across the globe, Indian, Singapore, Australian, UK, US, Canadian, doesn't matter. They're all there for you to use. You have to know what you're placing. Same with the ductwork, has its duct tool, you place the ducts, components are there, then the fittings are associated to the components and build the relationships relative to your duct sizing and the angles that you're placing. Same with the cable trays, there are some interesting varieties available in both tools relative to cable trays, plus the ability to customize and build your own. And then uniquely, something why I like comparing Revit and EcoSim in a presentation like this, you're actually able to share content. So now I can take a Revit family developed by content specialists and actually apply it on projects, whether the project is a Revit project or a Bentley project. Bentley built this thing called a Revit analyzer, a Revit family analyzer. So I essentially load the family, I map its attributes, and then map the Revit properties relative to EcoSim properties, and you place it. Sorry, I didn't go there. And it's as simple as that. And this was they did this about 4 years ago, all in the name of interoperability. So they realized that there's never going to be Bentley only projects. So they said, you know what, we're going to have to share on the projects where Revit is at play with Bentley. And in my history, I've been on several projects of that nature where the two have collided, and very difficult, I must say, when you have, let's say, architectural doing Revit and structural doing EcoSim. It's different, but it's doable, needs coordination, but the ability to share families across platforms is something pretty cool. Something else, this was a research project I did with the University of Toronto. We said, could we take an IFC file and open it and edit it in both Revit and EcoSim? So this was just a little prototype that we did there, but it's just to show the possibilities. We made a little applet. We inserted it in as a Revit add-on. You entered a comment in Revit to the IFC file. We opened that same IFC file in EcoSim, entered another comment, and it registered the second one. So now they're both there, one comment entered in one platform, one comment entered in another. The thinking here was, if I can get people to comment in the software they're familiar with versus introducing a third review software that we'll talk about later on in this presentation, is that a good thing? So it was just it was a school study for one of the BIM courses at University of Toronto. And I thought, you know, kind of cool that you're able to actually impart a tool that touches the Autodesk and the Bentley platform to catalog and quantify the comments. That's all it was. It didn't go anywhere, but I think why I like showing this is it opens up the possibility to say, you know what, you can be in multiple platforms, and you see in the last comment there, the comments can be viewed in an IFC viewer like Celebri. So take a viewable, you know, a static snapshot of BIM, look at it in Revit, look at it in Bentley, look at it in an IFC tool, and we're all commenting on something common, but in our own familiar environment. So maybe there's potential there down the road. But that's, you know, that was the point here, and this is it inside Celebri. So, you know, quick view of the building world. In the world of IBI, we are a Revit-focused company. But there are example projects where the questions have been asked. You know what, hey, it's a Bentley deliverable. What do we do? Should we do Revit? Should we do EcoSim? A lot of people don't even know that there is a Bentley EcoSim. EcoSim stands for Architecture, Engineering, Construction, Operation, Simulation. So it's a ridiculous name in my opinion, but it's, you know, it's basically Bentley's Revit, and then there's the other tools as well. So familiarity for me is step one. The world of building BIM, Revit is the most prominent, and the fact that IBI is focused on it is awesome because we're building our abilities. But we just have to make sure that we're cognizant of the fact that either we may have to work in something else if it's driven by a project, we may be exposed to something else, we may have a sub that gives us an EcoSim model. What do we do with it, right? There's stuff that can be done. So let's talk about civil tools for a moment. I'm going to launch this other poll, just again asking for familiarity. So again, the question is, you know, what have you seen or heard of? And then we'll give it a couple seconds here. Awesome that everything has been hit at least once. That's good. Okay, a couple more seconds for it to die down. So as I expected, 80% of people have heard of Civil 3D respondents, 18% inroads, 11 Geopack, 47% ArcGIS, which is great, and then 2% MX, which I didn't think there was going to be a big take-in on that. So that's cool. Okay, let me close that, and we'll go on. So Civil BIM is very different. So it's the linear infrastructure. It's about, you know, the terrain modeling of the site. So the undulations, the levels, the different stratifications of data that consist within the layers of your site. Very different from Building BIM and, you know, the vertical infrastructure associated to it. Civil BIM also takes into account the you know, the piping networks and the movement of or flow of content from one site to another, or from various facilities within a site, or rail projects, so the movement of rail from transit stop to transit stop. Talking specifically about Civil 3D, the intriguing part of Civil 3D, so unlike Revit, Revit has a central model, everybody's pinging to that central model. Civil 3D is AutoCAD files, so you can have hundreds of files. It has what's called a data shortcut project. So that data shortcut project actually holds information that you'd want to harness across the hundreds of DWG files. So the example there in Civil 3D, I'll make a pipe network and I'll call it pipe network 1, or I'll make an alignment and call it alignment 1, whatever it is. The point is, if I make alignment 1, I don't want you making alignment 1 and setting it differently. So instead, I make it, it gets synced to this data shortcut project, and when you open the file, you have the same alignment 1. And as we're growing accordingly, we're building the data shortcuts, and we're sharing those across the vast network who are working on the project. Now you can imagine from a collaborative perspective, sharing a Revit Central model, there's fun and a solution required there. Sharing data shortcut projects, equal fun, equal requirement for a solution. But that's how Civil 3D, the backbone of it works relative to setting of the information and sharing it across the globe. Now, as I mentioned earlier, it's rare to have a BIM project where everybody's using the same application. So I'll say even in a Revit project, if you have ARC, Struct, and MEP all using Revit, there's still a site. There still has to be some interaction between that building model and the site model. Now, if the site's just being done in 2D AutoCAD, that's one thing, but if it's done using Civil 3D, then there is that question of how do I interact between Civil 3D and the coordinates and Revit and its coordinates, and how do I ensure that I'm seeing the data back and forth? We have workflows to address all of that. Bentley Open Roads, this is what Bentley calls a technology brand, if you will. So it encompasses the 3 applications of Inroads, Geopack, and MX. Now again, don't quote me on the history of it, but I believe MX was acquired, and I can't remember about the other ones, but the point is that they were, as far back as, as early as just 2 years ago, 3 distinct applications that Bentley had. This Open Roads concept was to brand them all together as their Civil BIM solution, and they harness a common technological backbone, even though the user's interface may be different. Similar concept to Civil 3D, there's a backbone data makeup, but it's using, it's almost like a federated file, if you will, that's shareable across all of the users. So I build data into a digital terrain model, and that data is harnessed across multiple users who are accessing and building into the DTM. Then from that digital terrain model, we can either visualize and build triangulation, do plan and profile, automatic section generation, a whole bunch of good stuff that can follow up based on this, as well as I can bring these civil models into, whether it's Bentley, Autodesk, or other, into other software for design review, which we'll get to later on. But I just want awareness there, because there are a lot of client agencies that may not have an opinion on the building, but have a heavy opinion on the civil, and require either the use of one of these tools or the delivery of DGN files to build into their databases, whether it's provincial-wide, municipal-wide. A lot of the DOTs in the states have a heavy requirement for delivery in DGN. Revit has site tools, and I bring this up here because there's a lot of confusion when people open up Revit and say, well, we'll get our civil modelers to use Revit because you can do this. Right? And I describe these as they're simple site representations, but not to be confused with the engineering applications that Civil 3D and Inroads, Geopack, MX have as integral to them. So, I, the architect, I can do something like this to visualize or to convey my intent, but it's by no means a engineered solution. And I think that's the clarity we need to bring. And oftentimes the engineers would say something like this causes more havoc than it does good. So that's an intriguing debate, and that can be obviously debated. But these tools do exist inside Revit. The nice approach is when you have content from an Inroads or a Civil 3D exported to a format that can be pulled into the Revit site tools, then you're able to say, great, I can now visualize in Revit what's been designed in the civil tools via this exporting workflow. And again, all of these are just diligent workflows that we have to make sure that if we're looking to engage that, we're following that path of data from one facet to the other. Landscape BIM is a whole different beast because there is no answer. If you go to Autodesk, Bentley, Graphisoft, any of them and say, what's your landscape BIM solution? There's no answer. So what I like to show is there are possibilities, and these are the ones that IBI have dabbled with. So it's varying solutions. So if you're a landscape practitioner on the call, one day we'll say landscape BIM equals X, one day. So what I like to be a proponent of is if you're doing landscape or hardscaping around a building, so there's concrete slabs, you're building a concrete planter, and then you're going to landscape in the middle. So where you're putting the landscape design onto Revit modeled components and just building upon that, it makes sense to do it in the Revit environment because you're interacting with the source of that information. But when you're doing undulating landscapes or rail corridors, road corridors, Revit isn't really the tool for that. So you're probably looking at a tool like Civil 3D, where you can have the undulation of the land, and you'd be able to perform the landscape design relative to the network of road, rail, etc. that's being designed. Now, in Edmonton, we're piloting or testing out this LandFX tool, which brings landscape information, and you're able to schedule and get a bill of materials, etc., for landscaped content, and it works very well with Civil 3D. So there's a lot, there's demos that we can do on that itself, but I'd probably want to bring that to the landscape team so that they kind of see these three options and see where we've had successes using Revit and how far Revit's bounds can go relative to landscape BIM, and then how these other Civil 3D with LandFX give us a different facet with respect to the application of BIM from a landscape perspective. But again, this call, I just wanted to bring awareness to this because, again, I'm not sure how many people are familiar with what solutions have been tried, and then if there's others out there, we'd want to further explore those within the landscape group. Then lastly, GIS, and the fourth session, BIM for Engineers, we went through GIS. So I'm not going to expand on this, but Esri ArcGIS is a tool that we have. We have a collection of maybe 20 global practitioners that touch GIS. And GIS is essentially spatial data information relative to assets in built form. And what Esri allows you to do is build various data layers to turn information on and off and visualize it and query it in a manner as desired. So we have some great examples of GIS at play, delivery to clients, some web view maps that take some of our projects, expose them to the real world, and allow the stakeholders and consumers to query and interact with this information accordingly. So there's a lot of exciting stuff there. It's about data, it's about BIM, so there are workflows that could be put in place to bring civil and or vertical building information into the realm of GIS for portrayal, whether it's for 3D viewing in the ARC viewer, or whether it's simply to harness outlines and some fundamental data integral to those designs as they interact with the rest of the space around them. So within IBI, we actually touch upon Inroads, Geopack, Civil 3D, and ArcGIS. Civil 3D is the heaviest, used mostly across the globe. Okay, let's shift focus to plant, and what I'm going to do is open up the plant poll here. Similar question, which one are you familiar with or even just heard of? And we'll leave that open for a couple of seconds here. It's awesome watching the polls answer here. This is interesting. Okay, so roughly 30% on the AutoCAD Plant 3D, 20% or so with CADWorks. That's interesting. 16% OpenPlant, 15% AutoPlant. Okay, So now I feel bad I didn't make a CADWorks slide since 18% have that. Okay, I'm going to close the poll. Okay, so from the plant perspective, plant modeling is probably much similar to building modeling. But when I say that, we still run pipes along linear infrastructures as well, but usually that's done in the Civil 3D or Inroads tool. So when we talk about plant modeling, it's about modeling in vertical infrastructure usually, where we have heavy industrial piping or piping that follows a rigid specification backbone. So an example of that is, in the plant world, you can't place anything unless you know what it is. This is Bentley's Plant Space. So it's an older tool that I was first exposed to. And you quite literally have to select everything in blue there. If you don't select anything, it just won't let you place anything. As simple as that. So you've got to know what you're placing, why you're placing it. So what's flowing in the pipe, what material, is it pressurized, what type of facing do I want on my flanges, etc. If you don't know those answers, well, of course you can select anything and fake it, but everything I select here is coming from a spec database and it's going to be fed into a project database. And in the specifications for BIM, we talked a little bit about these plant database backbones. So this here is the example of the spec. So somebody has to set this, and that's what's intriguing about these plant projects. You can get things out of the box, but the rigidity around what we spec and why we do it all has to take shape in some form or another. And it takes time to build this. The vendors give you a really good starting point, thank goodness, but this is the complexity. You can see the limit of size. So if I pick this is what's flowing in the pipe, that's the size limit I have, and then there's restrictions on what I can place. So that's the beauty of the plant software, but it also could drive modelers a little crazy because they don't have the freedom to place anything. Bentley had another tool called AutoPlant, and AutoPlant piping is basically a similar concept. There's a database. Within the database, you've got a whole host of information, whether it's schematic information, so their PNID, process and instrumentation diagram, wiring instrumentation, pro steel information for structural, the plant design itself. So it pulls everything together and allows you to visualize it. But this was a tool that they acquired that worked only on AutoCAD. So it was an interesting commercial play, and this was about a decade ago, where Bentley said, we're going to own the piping software that all the DWG users use. And that's what they had. So inside AutoCAD, you launch your preferences, you're able to select your spec, your pipe size, etc. And then you go ahead and you place it in the model, and it just shows up in the pane, which is showing with respect to what's in the model. You could then query it and get a list of what's available within the spec and what can be placed accordingly. So AutoCAD said, enough of that. So then, now we're talking about 5 years ago, I guess, they came out with Plant 3D. So they said, instead of having to go to Bentley to do piping, we're going to actually offer our own software, which is great. Also native DWG file format. So if you're a Revit user out there, imagine like we already have built-in complexities. If we're doing a heavy industrial project, or if we're given a plant model, it's going to be in a format that's either DGN from Bentley, DWG from AutoCAD, and there's still going to be a workflow on how to make sure that I can bring this information into Revit to model around and reference where needed. The thing about plants, remember from the beginning of this presentation, plant is not IFC compatible. So there's no export to IFC and import into Revit, because these are plant-based tools governed by the other ISO standard 15926. But again, all these plant tools are very common. You've got schematics. Schematics are tied to your drawing. So the schematic here shows everything going from A to B across the entire plant potentially, and that could involve one or many facilities as required, and then we could auto-generate isometrics in bill of materials, etc. I was intrigued there. Not too many people were familiar with the smart plant, only 3%. So this is Intergraph's tool. So they're a whole nother vendor out there, and they're a very specialized software vendor focusing specifically on plant, and this is a very heavy application. Like we're talking the largest of plants in the globe would be using this. So they definitely don't target your everyday project. But again, it's all similar concept. You select what you want, you place the component, and you're limited by the backbone specs. The images I'm using here is actually the older version of SmartPlant, but it's the same concept. You see a lot of similarities here. And lastly, Bentley's OpenPlant. This is one I worked with in the past as well. Same concept. It's spec-driven. You're governed by what you see and what you're able to place. You're able to select various specs from various sources. You're bound by what's in that spec. Therefore, you're only able to place what the specification allows you to place. So from a plant tool perspective, IBI, definitely we don't have barely any use right now. We're exploring Plant 3D in our infrastructure sector. Right now, USA East is looking to pilot it on a couple of projects. So if we do pursue that, the building and civil users, just be aware that we'll have kind of this new kid on the block here interacting with our BIM models. So bringing it all together on any one project, and I've been on projects like this where you could have information from any one of these building, civil, or plant streams. You're lucky if it's just one. I've been on projects where we've had 2 buildings, 2 plants, and the 1 civil. So it could get rather complex when you have sources of data from various streams trying to come together into one. So I want to talk now, just throw up some model review options here, but I just wanted to launch one last poll here just to get an idea. Which have you heard of? And we'll just give it a couple of seconds here. And it's intriguing that the Autodesk products are always the ones that jump up. So that just shows, you know, the market share or the commercialization of how Autodesk markets themselves. It's quite impressive. But we have roughly 86% Navisworks, 26 Navigator, 16 Celibri, 19 3D PDF roughly. So that kind of shows the spread of the attendees on this call. I'll just give it a couple more seconds. Okay, we'll close that poll. Okay, so model review, the concept there is we want to pull everything together into one model for viewing purposes. The slides I'm showing, I just used a simple model example, just something I threw together, but it's to show it doesn't matter what tool you're using. It's the ability to bring it in. So Navisworks is great. So those are the file formats you may see. Navisworks can bring in almost anything, and that's quite impressive by it. So if you press that append button, the list of file formats you can get from you know, anything from your building, civil, and plant, but even more advanced things like Autodesk Inventor or SolidWorks, some of those specialty products for making components. Most of those can come into Navisworks. Usually if you're pulling in a Revit or a Civil 3D, most of the data is retained. If you're bringing in Bentley applications or other applications, you will probably get some data degradation, but that's okay. Depends, again, back to your BIM goals. Are we using something like this to review the model, to review the geometry, or are you using it to review data? And if you need to have your data intact, great care has to be used when you go outside of the BIM authoring tools. But again, Navisworks the most common. You can save views, drive through the models, sit down with your clients, get them to drive as well, and that client engagement is awesome. That just gets them right into the project. They have fun. I think they have fun. They must be having fun when they do it. So that's Navisworks. Navigator is Bentley's version of Navisworks. It uses this iModel format. Now, if you've been following social media quite a bit, you know, Bentley is very adamant on the iModel format, so it's their own proprietary format, different from the next slide where we're talking about IFCs. But the problem with this format, it is Bentley only, yet Bentley has gone and built plugins to tools like Revit. They're working on Civil 3D. I believe they have ArchiCAD, SmartPlant, etc., where they say, model in whatever you want, we'll give you the plugin to pull it into the iModel format, and they maintain data plus geometry. So everything that I built in Revit appears here in the Bentley Navigator format. And it literally is, and I'm always afraid to say it's a push button to get you to these formats, but it essentially is. You open these applications, you point to your models, and it sucks them in, and whatever it can read, it can read. So Bentley's done a lot of work to make sure that the data shown within this items tab here is the true data that comes from the authoring tools. And they've done specific focus with Revit to try to build that interoperability between Bentley and Autodesk. Now IFCs, that's that ISO standards for buildings, so industry foundation classes. It's a great concept. It's continuing to grow. It's shepherded and sponsored by the Building Smart Alliance globally. IBI is an active member in many local chapters of Building Smart, and the growth of the IFC file, they're about to release IFC version 4, which is supposed to have greater ability to leverage the information, to leverage views from BIM authoring tools, and to have a better interactive experience with the data within these tools themselves. There are a couple of tools that I'm showing here, Celibri, BIM Site, and DDS CAD. There's definitely others that can read the IFC format. The critical thing, it's under this mantra of Open BIM. So you model in whatever you want, you get it out to IFC. The IFC holds as much geometry and data as it's configured to do. And that's the critical thing, is that the intent is for it to hold as much as it can. You may hit the barrier of the current IFC 2x3, which is why IFC 4 is coming out to enrich that entire experience. It's a static snapshot, so you can go off and continue modeling and deliver this IFC file out to a consumer or a stakeholder. Similar concept, a little lesser than the IFC, is the 3D PDF. It pulls over a good deal of information as well as views and setups, etc. So you can hand this as a PDF file, readable in any, I think it was Adobe, goodness, I think it's 7.0 or greater, so we're well beyond 7.0. Most of your clients, stakeholders, or anybody in the world would be able to view this file. In my experience, we've broken this, so the models have become far too complex in order for it to work. But I'm talking like major plant projects, super high-rise buildings, etc. But this example model, you can swing around in the 3D PDF and it would work beautifully. And then just some mobile applications. So on your iPads, Android tablets, you can bring in a model, navigate around like a gaming console, select items and see their data attached to it, hide components, measure, etc. And this is Bentley Navigator Mobile that I'm using, but the BIM Glue Mobile would do the same. There's a whole host. If you go to the App Store and type in BIM, there's a whole bunch of applications that you can download. Some read certain file formats, some only read others. You have to be mindful of that when you're trying to get something onto a mobile device. So a bit on other tools, and we should close close to the top of the hour here. So we talked about building, civil, and plant authoring. We talked about model review. A couple here now from a conceptual perspective. A lot of people use SketchUp, and SketchUp is becoming more and more intelligent as the years come. And I say intelligent with air quotes because it's able to host some elements of BIM information that can then be either harnessed or viewed when furthered into tools like Revit or EcoSim or ArchiCAD, etc. So the idea is you could start a conceptual design using a tool like SketchUp and then migrate what's migratable, if that's the right word, into a BIM authoring tool. Now some Revit users would say, well, why use SketchUp when you can use Revit? And the SketchUp users would say, well, I use SketchUp because I can't use Revit. So it's all good, it is what it is. But just know that oftentimes, like what you see here will not go wholeheartedly into Revit. You'll get parts. Oftentimes the Revit modeler might use it as a backdrop and just remodel to make sure everything is proper BIM authored properly within the BIM tool. But these conceptual tools do exist. We also have InfraWorks, which is more like a civil-based conceptual tool offered by Autodesk. So its benefit is it can take information from Google Earth, aerial photography, etc., allow you to model a design intent, and it'll actually interact with that existing information, and once you get it to a point where there's a comfort level, you can push it into a tool like Civil 3D and further the design from a full engineering and BIM perspective. Point clouds are awesome when used properly. So if you receive point cloud information, we want to analyze it and make sure it's usable from a BIM authorship perspective. So we have tools like Autodesk Recap or Bentley Descartes. The idea there is pull in the point cloud, get it ready for use, and then make it available for referencing or linking into the active BIM models. Never try to import a point cloud into a BIM model, and don't always leave it on, because these things are massive, and you can just imagine the level of detail there, and thus the size of these files in order to portray accurately the information that's there. But they are beautiful tools to get pure ultimate representation of what's actually there on site, either before a design or to validate in the as-built conditions. They are great. 4D schedule simulation, we talked about this actually in the BIM for construction. I use it as another tool because this isn't really something architects and engineers will delve into, but just know that our BIM models are going to be pulled into some type of a scheduling tool, whether it's something built into Navigator and Navisworks, or whether it's one of these other Synco Pro. I've never seen Ask the Power Project. I've seen the Vico Office Manager. The idea is brings in a schedule from Project Primavera P6 or others, and you can see the schedule there, brings in the BIM model, you assign components to scheduled tasks, you run the simulation, and it will show how this thing grows over time. And I like this example here because it not only shows the building, but the temporary works, the cranes, as well as the infrastructure around. So there may be logistics around how to get the cranes on site relative to the rest of the components, and then how to manage the materials coming in and out. So just be mindful that our information, when turned over, or should I say if turned over, will be used in some sort of format like this by a contractor. And then there's fabrication tools. So I wanted to mention Tekla because that comes up quite a bit. And Tekla really, I would say, brings your model from the level of development 300 to a 350. So it takes your steel design and designs the connections and the details and makes sure it's buildable. And in theory, in the perfect world, you can fabricate directly from this assembly and go straight to site. But most likely this is where the organization using Tekla will develop these details, print your or create the shop drawings, apply the professional seal that we call for in our specs for shop drawings of this nature, deliver them back to us for shop drawing review, and then deliver them to the contractor, which we would then review, and then the components get delivered to site after fabrication. So that's kind of where Tekla fits in. I'm not familiar with design firms that would use something like Tekla over a Revit or an EcoSim, but we may come across that where people are trying to further Tekla and get it used deeper into the design stream. And then lastly, I wanted to just quickly show component data management. So this is where tools like Codebook or DeRufus, there's FM Systems, Archicad, Archidata, sorry, a whole bunch of these tools that are out there, and we talked about them at the BIM Asset Management. But these two examples focus on room data sheets specifically, and you're able to take in a Revit model, understand the spaces, have a database of assets that have to go into each space, and then you have a relationship between what's in the Revit model, what's in the asset database, and you can compare back and forth. So some powerful tools. Codebook is used by IBI in the UK, and DeRufus, we've done some exploration on it for potential application. There are others, and that's part of the problem is when you get beyond the BIM authorship, there's a whole host of tools that are either cropping up into the industry that have to be evaluated to see where and when there's applicability. And lastly, visualization. I'm not even going to delve into this, but this is where you'll hear tools like 3D Studio Max. So that's where they develop a model for visualization purposes. I want to be clear on that. They'll take the BIM models that are built for the defined BIM uses, and they can either use them as a base or use them as a reference in order to develop what you're seeing here. And this is just a snapshot. If you've engaged the advanced rendering team, this is one of the interfaces that they look at when they're developing their models. So just to close, a couple concepts on sharing, and I'm not going to dwell on these. We can spend hours on these alone. But if you had an Autodesk project that had to go in, a Revit project that had to go into Bentley, quite literally, there's a publish button that's inside the Revit interface. It creates an iModel, and it makes it available for others to use inside the Bentley world. And I'm using a common graphic model for all of these, but what this is showing is that's a Revit model inside Bentley, plain and simple. Push a couple buttons, whatever it sees in Revit, it exposes into Bentley. And this is 3D. This doesn't deal with CAD standards or like anybody's working on our major projects dealing with rigidity of CAD. It doesn't touch that. This is geometry and data. Other direction, I can have, from the Revit perspective, getting out into AutoCAD or MicroStation. That's where we have the exports, DGN, DWG. Get it into whatever system you're using to collaborate, your server, whatever other advanced system you're using, and you see it inside the MicroStation world. Very simple. Bentley or AutoCAD into Revit. There's a couple things we can do here. Now, the easiest and the most straightforward, and this is the last one I'm going to show, is just the simple link. You browse to your DGN or DWG, you position in Revit, and you model accordingly. And what I'm showing in this image here, if you can see those red lines, that's a piping model. That's inside the Revit. It's just, again, it's a blob. It's a graphical blob for you to model around to know that, hey, you know what? I can't put a column here, there's going to be a pipe. Now, if it was all buildings, this is the difference. If it was EcoSim and I can go into the IFC format and bring that into Revit, it would be a whole different world. But this is your bare bones. I've got a plant model using OpenPlant, or I might have a civil model using Civil 3D, and I just want to have the graphical representation in my Revit model so I can model around it and know that I'm modeling correctly. Things can be done to achieve that. What I'm showed here is not the best, it's not the worst, it doesn't matter. The point is, if you have a project that has multiple tools at play, it's doable, but it must be planned. That's the only way to say it. You've got to have a BIM lead on that project. We've got to know the scope of the ramifications of what we've bid on, and we have to address it accordingly. And of course, that's what I'm saying here. So for the most part, geometry can traverse platforms, multiple platforms. The geometry can be shared. Data does not always. So as I said, some can go through IFC. Some it's just geometry, dumb information that'll show inside Revit. Use the project BIM lead. Additional coordination will be required when there's multiple platforms at play. Additional coordination is required when we're doing more than just creating our drawings. So if we're doing other BIM uses, clash detection, design review, etc., somebody's got to coordinate the efforts. So the focus, as I said, is interoperability. One day we'll achieve this, and I showed this on a previous, for time, I'll just go through this quickly, but imagine a model that's being authored by tools from various vendors, and we have lifecycle data requirements, right? It's doable. When I first made this slide, now 6 years ago, this was a pipe dream. 3 years ago, it became a little more real. Now it's even more real. It's not perfect. I can't start a model in each of those 5, 6 softwares and say I have a seamless, interoperable project, but I can have a project that could work with effort. End of the day, want to plan, scope, understand the intricacies, and identify the points of accountability. So for me, that's the project BIM lead. That's what we're going to be talking about in a couple sessions from now. And with that, I know I'm at the bottom of the hour here, or top of the hour, sorry. The next session, the invite will come out tomorrow. We're inserting in BIM and legal. That'll be next Wednesday. So I'm going to have the invite come out quickly upon completion. BIM collaboration is at the end of August, and Project BIM leaders at the middle of September. So with that, I'm going to just pop open the question pane, knowing that we are short on time here. So the question, the LandFX image looks like SketchUp. Is it a plugin for SketchUp? I believe LandFX has something for SketchUp as well, Matt. That's something we can follow up with the Edmonton office. Our focus has been the Civil 3D side right now, but I honestly, I cannot remember if it was. LandFX is a third-party purchased by Autodesk, so it very well could have tie-ins into other tools. Can we have the PowerPoint? Yes, the PowerPoint, just while we wait for other questions to pop up here, the PowerPoint is on the IBIU site. So if you know how to get here, just very quickly under the info page, if you go to training and if you go to IBIU, you can select BIM, and then on all of the information for the BIM courses are here. So I haven't added it yet, but I will have links right here for the video, the PowerPoint, etc. So it'll look something like this one here from last time. Okay, if there's no other questions, I don't see any AIA numbers, so if you didn't put an AIA number in, please just be sure to send the message to IBIU. Question here, Bentley has the RFA transfer wizard. Does Revit have a similar feature from Bentley to Revit? No, unfortunately not. So that's something that I've asked them in the past, if we could take advanced Bentley parametrics. So they have a parametric builder, which is a Revit family in Bentley terms, to pull those into Revit. And that's, I don't know if that's on the docket one day, not sure. Okay, any other questions? Okay, and I see people are adding in other numbers. Only AIA numbers. Any other numbers will have to be, you would self-report once the certificates are issued. Okay, I'll give a couple more seconds here to see if anybody else has any questions or AIA numbers. Okay. Well, thank you everybody for your attention, and I hope all of you can make the next bunch of sessions that we have scheduled. Have a good day, everybody. Bye.